Hello and welcome to another important discussion. It's an exciting discussion about electric power. We define electric power as the rate at which electrical energy is spent. Now, electrical energy, as we had seen in the last class, is all about how much heat is generated when a wire is running electric current within it. Now, so we can understand it in this manner. Suppose if we have a wire and that wire is having some electric current passing through it, and let the electric current that is passing through the wire be of magnitude I. Okay, and we have seen that the electric current passing through this wire actually heats up this wire, and the heat generated in the electric current, we have seen that it is equal to I squared, that is a square times the current passing through the electric wire, into R into T, that is the time for which the current flows through the wire. So that is the expression for the electric current heating effect, and this heating effect, this heat that is produced, can be considered to be the energy dissipated when the current is flowing through the wire. And when we are saying that electric power is the rate at which energy is spent, so we can say that the power is actually equal to the energy. So the energy is suppose E, or it can also be written as H, because that is the energy actually, divided by T. So it is the rate at which energy is uh, actually spent or consumed. So we can write that as I squared RT on the numerator side, and in the denominator we are already having T. So the T from the numerator and denominator gets cancelled out, and that leaves us with P equal to I squared R. And that is a very good expression for calculating the power of a device if the current passing through it is known and if the resistance of the device is known. We can also do another thing over here, and that is we can take this I separately and then another I. There are two I's over here due to this I squared, so that other I can be just clubbed with this R. So we have this IR over here. And if you people remember from the earlier discussions that we have an expression called the Ohm's law, which states that V, that is the potential difference, is equal to I times R. So this I into R actually is V. So instead of this I into R, we can put V over here, and that gives us P equal to VI. So potential difference times the current flowing through the wire. We can do another thing, that is we can use this Ohm's law once again, and we can actually substitute the value of I. From the Ohm's law we have that I is equal to V divided by R, because this R over here, it can come down to the denominator, and so we can have I is equal to V divided by R. So in place of this I over here, we are going to plug in the value of I from this expression over here. So what we are going to do is we are going to take this expression for electric current, that is I is equal to V by R, and we are going to plug it over here in the place of I, and what we will get is very nice expression. What we'll get is P is equal to, so in place of I, now we are going to put this V by R. So V by R, and since it is I squared, so we have to put this thing in square. So we put a bracket around it and we put a square. So V by R whole squared times R. So times R. So we write R over here. What do we get as a result? We get this, we get V squared divided by R squared, and here there is another R that is being multiplied with this expression over here. So this R gets cancelled once with this, And so finally we have P equal to V squared by R, and that is another expression for calculating the power of a device, the power dissipated, whatever way you may look at it. So in fact we are having now three good expressions for the expression for electric power. First we have one expression over here, and that expression is very the most basic expression that we are already we have seen that, and that is P equal to I squared R. That is our first expression that you should remember. The second expression is this one, P is equal to V times I. That is the second expression for calculating power, and the third expression for calculating power is this, P is equal to V squared by R. So these are the three expressions, and these expressions you should keep in mind while solving numericals for power. We'll come back in our next video to discuss about some numericals involving the power of a device. Now we just concluding remarks in our mind. Concluding remarks, let me tell you that the SI unit for power is watt. You must already be knowing that from your earlier experiences. So the SI unit for power is watt, W-A-T-T, after the great inventor and scientist James Watt, and it is abbreviated as uppercase W, capital W. So that is the discussion for now. We'll come back after a short break. Thank you very much.